Good afternoon. This is Dion Knowles from TecQuipment, and welcome to this live aerodynamics presentation webinar from myself, Dion Knowles, the marketing manager at TecQuipment, and I'm also joined by Dave Giddings. Today we'll be providing a teaching overview, practical teaching overview for aerodynamics. Welcoming Dave.
Hi there, Dion. How are you?
I am good, thank you, Dave. How are you?
Yeah, feeling great, thanks. Feeling good.
Fantastic. Right. So at this point, everybody should be able to see our screen. And I would like to remind everybody that if you're watching this live, you can put your questions in the comment box and I will ask them to Dave during the course of the webinar. I'm monitoring those on my second screen over to the right of me. If you're watching on demand, which many of you may well be doing later on, then you can put your questions in the comment box. So sorry, it's when you're live, it's in the chat box, and when you're on demand, it's in the comment box. It'll all become apparent as we go through. Yes, absolutely, Dave. Simple. So we'll get underway. Many of you, I'm sure I know out there, and you'll know me, some people will be new faces. Do feel free to put your questions, say who you are in your comment box. I'll give you a shout out. Let's have a bit of interaction during this webinar. As many of you already know who TecQuipment are, I'm going to keep it brief in terms of providing a company overview. This is what we'll start with. Many of you know that we're a worldwide organization. We have a worldwide presence. We have customers in more than 100 countries within more than 1,200 different organizations. As you can see, we've got some examples here of the University of Regina in Canada, Solihull College in the United States, in the UK, East African School of Aviation, Bangladesh Military Academy, just to pick a very small handful of different institutions. Key facts about TecQuipment, if you don't know about us, we have an annual sales of 9+ million, 90 employees, but what's important is we work together from our headquarters in Long Eaton, United Kingdom, where we design and manufacture everything all under one roof. But we work with sales partners all around the world that have an established relationship. In many cases, we have years and years of experience of working with those individual organizations. As an organization, I'm not going to talk about the history. If you'd like to know more about how we were established 62 years ago, you can look on our website for those details. But there's some principles that I really want to share with you about what we believe in, how we approach our product development, support for educational institutions around the world. And I want to tell you a bit now about how we focus on developing skill sets. We're all about creating the best products for practical teaching. Of course, we want to say we're the best because we're talking about, you know, ourselves. So I'm sorry if that seems a bit arrogant, but we do believe we are committed to developing the best. So it sets the bar high for everybody across the organization in terms of a true belief in high quality, where equipment will last year on year. We want to deliver practical teaching equipment that is about real life understanding. So it's taking the theory, putting it into the real life, but matching that to the skill set that's required today. Not 20 years ago. It's those understandings that engineers, tomorrow's engineers, need to deal with also tomorrow's engineering challenges. And we're also more than just about products. We very much believe about holistically assisting in the teaching process, whether that's bringing together communities on LinkedIn and Facebook of academics around the world, whether it's motivating students through competitions, whether it's educating the market as to perceptions, and I'll come on to talk about that shortly. I'm really conscious that you're here to learn about aerodynamics and teaching principles, so I'm going to try and keep this bit brief before I come on to that later. We have three very distinct principles of product design. It's about fostering curiosity and sparking passion with the student in mind. We also believe in having products that will stand the test of time, as I mentioned earlier, and also having teaching equipment that is better performance and more effective experimentation. We are minimizing the downtime in the labs, that is filling up hydraulic benches, for example. So that's some things that you need to know, you may like to know about what really motivates us, what are the principles behind what we do. And we're about also simplifying teaching. Yes, we want to spark passion. We want things to last a long time. We want things to work, perform better, make the most of lab time. But we also want to make sure that we match your syllabus requirements, that we provide supporting teaching material. That's a really, really important aspect of what we do in terms of very, very comprehensive manuals that we offer and the videos that we offer as well. Now, less about me. I've raced through that at hyper speed, conscious that what you're really here to do is talk to Dave, is listen to Dave and learn about what we do in terms of teaching aerodynamics. So Dave, this is your point. I'm going to hush my mouth. Quiet. Well, you take over.
Well, dear, I can't carry on without just mentioning that I love the word holistically. It's a fantastic word. Okay. Yesterday I told you how much I dislike the word unprecedented, but today holistically it's sweet. I love that word. Okay.
I embrace the holistic elements of your life.
I'm going to use it for the rest of the week. Anyway, so
okay, I hope you'll be flying high with that, Dave.
Oh.
Sorry, I have to get in there with the first pun. I had to get in there before you.
I can't compete with that. That's mature cheddar on the cheese scale. That's awful. Okay, so what is aerodynamics? Well, like the button says, it's the study of objects in motion through the air and the forces that produce or change such motion. We'll come on to a little bit more detail on the products later, but so who teaches aerodynamics?
You tell me, Dave. I'm supposed to be driving, aren't I? And I'm trying to deal with my comment box as well.
I'm the backseat driver, and you're supposed to be at the steering wheel.
I'm supposed to be steering this. Sorry, I'm on track. Focus.
So yeah, we find our range of aerodynamics in universities, in aerospace colleges, schools, aviation schools, military training schools. Within those establishments, we tend to work in aerospace departments, aviation, even thermodynamics, civil engineering even, and propulsion, of course, with the gas turbines that we offer. And there we have the subject areas within the aerodynamics umbrella. We have obviously aerodynamics, aerospace, airflow, aircraft studies, aeronautics, thermo, and structural and fluid mechanics.
Dave, before we go any further, could you tell us, I mean, some of the topics that you're going to come on to talk about in terms of practical teaching, you're going to be talking about Mach numbers and aerofoils. Could you lay the foundations on those for us?
Yeah, well, we will be talking a lot about Mach numbers and aerofoils. So Mach, the word Mach is named after an Austrian physicist and philosopher, Ernst Mach. He discovered that the speed of sound is 761 miles per hour. Okay, so a Mach number is a ratio of the object speed, be it a plane, to the speed of sound. What does that mean? Well, a Mach number equals the speed of the plane or object divided by the speed of sound. Okay, I'll give you an example, Dion. If a plane is flying at 761 miles per hour, and we know the speed of sound is 761, then that divided by that equals Mach 1. Okay.
Okay.
If we are looking at a Mach number less than 1, that means the object is flying less than the speed of sound, and it's called subsonic. Now, these are keywords that we'll see later on, and also plastered in our product range. Okay. If the Mach number is roughly equal to 1, that means the object is approximately flying at the speed of sound, and that's known as transonic. So we've had subsonic and we've had transonic. Okay.
Okay.
Now then, If the Mach number is greater than 1, that means your object or your plane is faster than the speed of sound. That speed is known as supersonic, okay? And finally, if the Mach number is much, much, much greater than 1, so that means the object is flying much higher than the speed of sound, then the speed is known as hypersonic. But we don't get into hypersonic. That's not in our field of or scope of teaching.
All right, brilliant. Thank you, Dave, for that
Okay.
rundown of Mach numbers.
No problem.
Right, so what do you want to talk about next? Practical teaching of aerodynamics, or are we going to?
Not quite. I see also there's a question about aerofoil. Again, I may be talking quite a bit when we talk about our wind tunnels about aerofoils. What's an aerofoil? Well, in the UK and most of the world, it's an aerofoil. However, stateside in America, it's an airfoil. Okay,
Oh,
so there's a little bit different there. We're not a little bit different, but aerofoils, they are found everywhere in modern life without you probably realizing. We will find them in propellers, okay, cooling fans on your desktops, compressors and turbines. We will see the aerofoils there. On a ship or on a yacht, we have sails and we have keels. An aerofoil shaped can be found underwater, like I said, on a yacht. In which case, it's a hydrofoil. It's a hydrofoil. Lots of nature has aerofoils, swimming objects and flying creatures, and many plants employ aerofoils. Okay, so it's not just what you see on the side of the aeroplane. Now, each aerofoil has a code. Okay, it's an NACA number. And I'm going from memory, that stands for National Advisory Committee for Aeronautics, NACA, NACA, okay? And your shape of your aerofoil is described using a series of digits using the word NACA, okay? And those numbers can be entered into our equations, in fact, in our manuals. Normally 4 digits, Dion.
Okay.
The first 2 digits describe the distance of the camber to the chord. Okay, this gets a bit technical now. And the last 2 digits, they describe the thickness of the aerofoil as a percentage of the chord. Okay.
As a percentage, not the actual thickness.
Percentage.
So as you can scaling it up, you can still be within scale. Yeah.
In our product range, you will see NACA 0012 and various other NACA numbers. They are referring to the NACA. Okay, so there's a little bit of a going straight into the deep end on some bones of aerodynamics.
Marvelous. Thank you, Dave.
So practical teaching of aerodynamics. Let's have a look behind that. So here we have some good candid pictures of our labs. I recognize 2 of those labs for sure. The top left was in Alabama. I remember this. That was at Auburn College, Auburn University in Alabama, where I installed 3 subsonic wind tunnels and a intermittent supersonic wind tunnel. Bottom left is our friends in Solihull College, and I do believe top right is in Milton Keynes, Dion. I've not
Correct.
Been
that
there.
Is Milton Keynes.
You've been there a few times to do case studies and look at how Santa flies over the festive period. So that was good. And I'm not sure I recognise.
We've got Nottingham, Trent University down there. Okay. Yeah.
Well, I've been there a number of times. So yeah, like the middle button says, we have a selection of aerodynamics for equipment. It's an outstanding selection of engineering, educational teaching equipment, Dion. It covers a whole subject area of aerodynamics and airflow, right from basics all the way possibly to research level on the AF 1600 the much
Right.
bigger
Well,
working
let's have
section.
a look at these.
Let's see if you can pull it up
There we go. I'll
safely
zoom in
without
for you now.
crashing the system.
I don't know. My crash driving.
While you're doing that, I can just continue doing a bit of narrative. Our equipment are cost effective, low speed modular airflow bunches to subsonic and supersonic wind tunnels. Picture there, we see an AF10 flow visualization tunnel. That is an outstanding bit of kit. It's a good introduction to aerodynamics. We can look at boundary layers, we can look at Bernoulli's principles, and there's 8 different experiments in total. So very, very good introduction to aero. No data logging on there. We keep it simple. You or the students are the data logger. Then in the center, we can see the subsonic bench-mounted wind tunnel. Like I said, that's a subsonic, small working section, but still able to fit in some 3-dimensional models and some small aerofoils. Then we have an AF80 flow visualization. That's also a wind tunnel. It uses smoke to look at the flow patterns around certain objects, and that can be aerofoils. It could be a pinned heat exchanger to look at the patterns of airflow there. So a wide range of equipment there, Dion.
So Dave, when would you, for example, use the flow visualization wind tunnel versus the flow visualization channel?
Well, with the AF80, we're not looking at lift, pitch, or drag, or weight traverse. We're looking at the patterns of airflow around models, 2-dimensional models that you cannot see with the naked eye. You can't see that unless it's a very foggy day. So we're using a smoke generator. It's a CO2 driven smoke generator that creates some harmless smoke that travels around and through various objects, and it exhausts safely to the outside world, to atmosphere.
So that would be, I guess, about capturing a visual experience and really cementing the ideas in students' minds through this very visual experience, versus the flow visualization, where yes, it would be visual, but it's about taking measurements, actually really getting involved to test maths and theory. Is that correct?
And yet it's also great for prediction as well, because without the smoke, we have absolutely no idea what's happening on the trailing edge of the aerofoil that's actually stalling. We can't see the flow separation. We can't. Sometimes we can feel it in the wind tunnel with the chattering and the vibration, but we can't actually see it unless we use smoke. And if we've got the balance, we can see the drop in the lift, but we're relying on that instrumentation. But the AF80 actually gives you a real life visual demonstration of what's going off.
Right. Brilliant. And then you'd, I guess, once you'd gone, would you go incrementally from, say, the flow visualization channel, and then if you wanted more deeper understanding, then you get the subsonic wind tunnel? Or
well, do you know, it doesn't actually work like that, because I've been in labs and I've installed in, let's use an example, in Algeria at the military college, and they're using these equipments in parallel. They're using them in parallel. They complement each other.
Okay. So how would the benchtop wind tunnel complement the flow visualization channel?
Well, okay, so I'm demonstrating to you that this aerofoil, if I can just get a pen or something, I've got one. Imagine that's an aerofoil. I can prove to you with our instrumentation that it's creating lift.
Okay.
I can prove to you when we exceed 12 degrees angle of attack that we start to see a stall. Okay, but with the flow visualization, we can physically see the smoke separating from the skin of the aerofoil. So it's seeing is actually believing. It's very, very visual, and it certainly gets the attention of the students.
All right, brilliant. Thanks for that, Dave. I'm sorry, I was maybe labouring the point there, but I think for some people that's
what I'm here for.
Good. Make you work hard. Right. Let's look at the next step up. I guess. Here you go. It's going
Oh,
to
here
take
we
it.
go.
The hamster's going to run a bit faster, so you can see.
Yeah, so there in the top left is our subsonic AF 1300, our most popular wind tunnel. Lots of instrumentation can be attached. We can go analog with manometers and pitos. We can go for a digital approach with VDAS and differential pressure gauges and electronic pitot tubes. So the sky's the limit, Dion, with the AF 1300. Okay.
What kind of learning outcomes versus, say, the benchtop wind tunnel? What can you do that's so much more powerful with the AF 1300, for example?
Well, because it is much larger working section, as you can see there, it's 300 millimeters. That lends itself to using physically larger models, larger aerofoils. We can look at boundary layers inside the wind tunnel. We can look at cylinder models, pressure distribution around a model. We can use three-dimensional models as well, although we can do that in the benchtop, but it's a much larger scale.
Okay.
So we can do much more. We've got the data logging facility. We can fit the three-component balance, looks at lift, pitch, and also the twisting of the aerofoil or whatever models you've got. It does lend itself to a lot more, a greater range of learning outcomes than the benchtop.
Okay.
But in itself, that is also a very compact and a convenient wind tunnel.
And we do see people, students printing, 3D printing their own models for use in this wind tunnel and upwards. I think they'd probably struggle in the benchtop wind tunnel, wouldn't they?
Yeah, they would. I think so. Yeah, that tends to be more appropriate for the 1300 with their 3D printing approach, which is very popular in the States, I must say.
Okay, and we've got some good videos from students at Nottingham, Trent University who've entered the student competition, who've 3D printed their own models, whether that's helmets or whether it's spoilers for cars, and wings as well, I think. So, but I'd encourage people, if they are interested in getting some ideas for their students, or if you're a student yourself working on a project, then have a look at our YouTube channel, search Nottingham Trent University Student Competition, and you'll find some really inspirational ideas there.
Yeah, we should. You should. And then we move on to the much larger section wind tunnel, so the 450 millimeter up to the AF 1600 subsonic, still subsonic, but the 1600 can lend itself to a little bit of research in certain environments. That's really all I can say about the subsonic wind tunnels there, Dion.
Okay, here we go. We'll ramp up the speed, literally, and let's go to supersonic.
Yeah, well,
not hypersonic, definitely just supersonic.
So we have then our two supersonic wind tunnels. We have the intermittent that gives about between 5 and 7, 8 seconds of runtime at supersonic speed. Then we move on to the AF 302, that is continuous wind tunnel. That literally runs until you switch the power off, Dion. So they're the main difference. The learning outcomes remain the same. We're looking at pressure distribution along a Laval nozzle, various pressure tappings. Then with the help of the Schlieren apparatus, we can look at airflow, and we can look at pressure waves and shock waves around those two-dimensional models in the working section. Much smaller working sections on these, Dion, obviously because of the immense effort and power to get that supersonic wind speed through the working section. That's why it's about 100 millimeters by, I think, about 25 millimeters working section, much less than the subsonics, as you'd expect.
Now, we were talking about this in our live Q&As yesterday. We're talking about it actually freezing inside of the working windows. Go and tell us more about that phenomena.
Well, I've actually seen this happen in Bangladesh Air Force Academy in Bangladesh, obviously, where you have condensation shock, where the humidity of your ambient air is so great. So in Bangladesh, it was something like 85%. You could feel the moisture in the air and on your glasses and on your skin. So when it's speeded up, the air cools down rapidly, so much so that we had ice forming on the working section on the windows, and we could see it on the models fitted inside the wind tunnel. And to touch the top liner, my fingers actually stuck to the working section, such was the humidity. And because of that, we could not get to Mach 1.8 the first time I visited. So they had to install some heavy duty industrial dehumidifiers and also some air conditioning units to get over that problem. My return trip there was a success, and we saw Mach 1.8. So that's the issue of condensation shock. It's real.
Right. Wow.
Yeah.
Okay. Good. Right.
There's one more. There's one more.
There is. Let's not forget about the little one in the corner.
There's the AF41 flight demonstration wind tunnel, and that's where they get to actually fly a plane inside of that suction type wind tunnel. We are able to deliberately make the plane stall. We are looking at the center of gravity of that plane. We look at the altitude of the plane, the attitude. Now, attitude in this context is not waking up in a bad mood and having to go at your kids. This is the angle of the plane in relation to the horizon. Okay.
All right. You suggesting I might have some attitude this morning, Dave?
Absolutely no.
I'd say it was the other way around. The kids waking up with the attitude.
No. And then we look at the wind speed as well inside the wind tunnel, which is measured in knots in this case. So that's three more of our wind tunnels that you see there.
Great. Well, we move on to now looking at case studies from around the world. You've travelled around the world, haven't you, Dave, installing various different pieces of aerodynamics teaching equipment.
Oh, yeah. Well, let's go counterclockwise. Let's look at Bangladesh.
Okay.
Been to Bangladesh on many occasions, installed mostly aerodynamics equipment there. So I've already mentioned BAFA, which is the Bangladesh Air Force Academy. That's in a town called Jashura, and they have what I would call a showcase lab. They have the continuous supersonic. They have multiple AF1300s, not just one. I think they have three from memory. I'm sure they have two or three. Anyway, they have the flight demo wind tunnel. And to complement that, in a lab next door, they have the small engine test set, the TD200.
Great, right. Where do you want to go next? Which part of the world?
Let's get back. Then we have Nottingham, Trent. Yeah, you've been to Nottingham, Trent. We have installed wind tunnels there, along with fluid mechanics and thermodynamics.
Yeah, here, people online, we've got a video case study. I'm not going to play it for us today, but there is a nice case study that looks at the use of aerodynamics teaching equipment, everything from engineering science, thermo, etc. So it's a nice all-round look at how one university is teaching mechanical engineering in particular, in this case, use the TecQuipment teaching products.
Yeah.
Right.
Getting back.
So back. I'm hoping my internet connection is unstable. So I'm hoping
well, I'll talk
it's
anyway.
grounded itself.
Yeah. So then we have bottom left EASA, East African School of Aviation. This role of mine has taken me there to install a lab pretty much complete. We've got modular airflow benches. We can see two, in fact, there. An AF41 think that's an AF 1300 at the back, or it might have been an AF 100 back then. So that was a very, very productive visit, and a lot of equipment, and a very successful install there.
Right, great. Well, I just want to do a quick shout out to Andre Bitaka. It's great to see you joining us today. I know Andre suggested it, and a few other people might well suggest it. Can we zoom to see the equipment, see a little bit more there, so we can have a look. But you can also see many of the pieces of equipment in individual videos. We've got demonstrations where you can look closely at different elements of the apps, whether it's looking at the VDAS screen, whether it's looking at the three-way traverse or the pitot tubes and the individual experiments there.
Yeah.
Let's have a look at another case study. Solihull College, what a great facility they have there, don't they, Dave?
We've both been there. We've had some great visits. We've also had some great inward visits from staff there. They have an intermittent. No, it's not actually continuous. They have an intermittent supersonic wind tunnel, 1300. They also have a GT 100 turbojet trainer. So yeah, some very, very good equipment there. Very useful to have a place like that so close to our factory, which is great for reference visits. And there's there's some pictures there of our GT 100.
Okay, University of Lincoln now. Dave, have you been to the University of Lincoln?
Just the once, and that was to do installation and training on their AF 1300. But I do believe you've been there since.
Yeah, I met it on. You can see there the video case study.
Yeah.
And we had a look around the whole lab. Actually, they've got they're teaching understanding mechanics at the University of Lincoln, so they're covering lots of different elements. Obviously, aerodynamics is part of that. So they've got an AF 1300 wind tunnel, and in that video case study, you can see that along with Dan's favorite piece of equipment, which is the static and dynamic balancing apparatus from the Theory of Machines range. So if anybody wants to have a look through that, and I encourage them to go on to either our website or browse through YouTube to find that. Next one, Texas A&M. What a huge facility they've just had installed. It's phenomenal, isn't it?
What a visit. That was nearly 2.5 weeks of install and training. That was at the Zachary building in Texas. Everywhere you turned, it was a showcase lab here, showcase lab there. Happy to say that TecQuipment performed fantastic there, pre-sales all the way through to the sign-off. The list is it's never ending. Fluids, thermos, aerodynamics. It was just a wonderful visit, and our relationship there continues with support right to this day. We're helping them. And all being well with a fair wind, we'll return there one day. So a very, very busy time we've had there. Yeah.
Yeah, sadly we haven't got any pictures of the AF 1300. I've just got various other fluid and thermo stuff on there. I want to say a quick shout out to David from the University of Wolverhampton. It's fantastic to see you. It's really nice when people put comments and let us know they're there. It reassures us that we're not just talking to ourselves, doesn't it, Dave?
That's true.
I can see the watch count all the time, but it is really nice to hear from you.
Splendid.
A reminder to everyone, anytime you can post your comments, your questions in the chat box, and I'll put those to Dave to answer to his best ability. Right, last case study now, or not the last one, but we've got a couple more. Milton Keynes College. I like this one because this is really fun. This is where we did a video where we proved how reindeer fly. If anybody didn't see that and have a bit of an enthusiasm for Christmas, I want a bit of a laugh. Then I check it out. Dave, you've not been to Milton Keynes, have you?
No, oddly enough, no. They were very comfortable in installing their wind tunnel.
Well, to be honest, that's because it's Sean Hainsworth, and Sean Hainsworth is from a strong background.
Oh yes,
he knows his stuff, and he's really passionate about what he does.
Say, yeah.
So you can see some of that in video case study that we've got. We've got a few other little clips on there. There's, as you can see, a picture there, a few students working with the AF 1300 wind tunnel.
Yeah.
Also want to say a big shout out to a few more people. Andy Ratcliffe, thank you. Matt Fellows as well, you're there. Wonderful to see you both. Great. Okay, so last case study of the session, East Africa School of Aviation.
No, we've covered that.
We have. I am losing track.
Come on, Dion.
Moving on. Let's
keep it together, Dion.
Well, that is, you know what, that brings the aerodynamics section to a close, but I've got a lot more to tell yet. So I'm hoping we can't, people won't leave us, because we're going to be talking about remote learning support, what we're doing to help people who are stuck in quarantine and lockdown, where students can't go into labs, planning ahead for scenarios like that. So what we have on offer. Dave will be coming back to give you a bit more of an overview of the ranges. So we're not just going to cover all aerodynamics, we'll skip over the other stuff too. I want to talk a bit more about our student competitions and surveys we did last year, and then we'll have the big Q&A session at the end. A few more shout outs. We've got Tono from Bolivia. Thank you very much for joining us. And we've got our TecQuipment's Bruno, who's here as well, and Silvio as well joining us. Brilliant to see you here. Do keep putting your comments in the chat box so I can shout you out, and put your questions in there as well. So I'm not going to be monitoring those comments so closely now, because I'm going to be presenting remote learning support at TecQuipment now during COVID-19. It's a real challenging time. Currently, factory is not in production. We are working from home, finding ways that we can best support academics and students and our sales partners around the world. So we're about delivering top quality customer support and assistance in that remote learning. We've got four main things that we're doing here. One of them is bringing together communities. We've got communities on LinkedIn and Facebook, the practical teaching in engineering education communities. And we've also got a public community on YouTube. So if you look at the fourth tab along in our YouTube page, you can find the community there. And that's something that students can also access as well. For example, I just posted a new video on there today from Practical Engineering's YouTube channel about culverts, understanding culverts. They do some great videos. It really, if you haven't already looked at Practical Engineering's YouTube channel, I'd check it out. They do not pay me to say that. I genuinely appreciate the videos that they provide. Providing resources, we have a whole resource area on the TecQuipment website. It is techquipment.com remote-learning-support. You can see it right in the middle there, hopefully. Now, what this is, this has a whole range of different pieces of tools that you can use, whether it's more information about our live streams, about our webinars. We've also got an engineering videos guide on there. It's got lots of videos, including the likes of the practical engineering videos that might explain how culverts work, day in the life of a civil engineer, that kind of stuff that you can use if you're an academic as a bank of content to incorporate into your presentations, to take your online teaching to the next level, to make it a bit more dynamic. So do check that out. We also have a growing number of student experiment videos, and this is thanks to, in many cases, students from Nottingham Trent University who entered the student competitions. So the student videos from 2019 and new ones that we're releasing for the 2020 competition as well. So we've got examples there where people have 3D printed their own helmets, as I was explaining earlier, tested them in the wind tunnel, spoilers for a car. But it's not just about aerodynamics teaching experiments in there. They've got thermo stuff, they've got all kinds of things. I can't remember them all off the top of my head right now, but do check them out on our channel. Next is if you are already a customer, it's worth mentioning that you can get hold of manuals that are unlocked so that you can incorporate the content easily into your online teaching material. So next, we've if you don't already know about it, every Wednesday, Dave and I host live Q&A sessions. Now, this timing on here is a little out on the screen. We now do them at 1 o'clock on Instagram and 2 o'clock on YouTube. So you can join us, ask questions live, watch it on demand. So YouTube is the easiest place to watch it on demand because it will stay there. You can check back at previous ones. This last week, which was yesterday, we had clinical psychologists talking about how to cope during COVID-19. We're just trying to find ways of supporting you in every way we can. Last week, we had the CEO and Dean of Teddy London, a new university that is setting up at the moment, which is based about project learning and student-led learning. Quite an interesting concept where they're really innovating in the way they teach engineering. We also, the week before, we had a lady called Dima Nasser. Dima is from a university in Lebanon. Dima talked about her career as a woman in engineering, particularly some of the challenges as a woman in engineering in Lebanon. That's a really, really interesting session there. So you can go back, find our live stream playlist, because we do have a dedicated playlist for live stream events, and go and have a look at those when you want. If you want, share them with your students, for example. And throughout that, yes, we have the guests, but we have Dave, and we've coined him Digital Dave. I know it sounds corny, but it kind of rolls off the tongue nicely. We have Dave on there answering questions, rather. I ask the questions, he answers them. We answer questions, whether it's about what's the most appropriate piece of teaching equipment for certain learning outcomes, whether people have got particular challenges getting their equipment to work right, anything like that, anything remotely technical about the equipment. Dave is our man, and that's the time to join us, and we will continue to those. I want to give a quick shout out to the University of Hertfordshire. Rachel Cunliffe, great to see you joining us today, and amazing Maya is with us as well. Good to see you. People of all ages joining. Right, let's back to support. Another thing that we put together about 3 or 4 weeks ago is thinking ahead to academics. If you're allowed back into the lab anytime soon, and in the UK, we might get more news on that on Sunday, fingers crossed, that we'll be starting to think of maybe academics can be allowed back into the labs, but maybe the students can't. And you're wanting to still deliver practical teaching content. Now, it's got its limitations. They can't get hands-on and start using equipment, but you could create your own videos. You could live stream, for example. We can give you some advice on that because we have had to build up our competency during this COVID-19 time. But this is quite a handy little video that you can use as a step-by-step guide, some tips of how to create your own little lab experiment video that you can share with students. Tips on lighting, on getting your sound right, on framing, even on editing, stuff like that. Very simple, nice and easy to follow. A couple of minutes, step-by-step tips video for you there. Great, so that's what we're trying to do, but we're always looking at how can we support you better. We need you to tell us that. That's the really important thing. If you've got something that you really need some help with, then we are here to help you. So please just reach out to us, send us a message, and we'll see what we can do. All right, okay, so Dave, stop munching those biscuits. It's time for you to return once more. You're up. And we'll talk about Range's overview. I can have a nap for a few seconds. Actually, no, I can't because I'm driving.
No, you can't. You can't. Well,
stay focused.
We'll just go around. Let's just go random. Let's start with engineering science.
Okay, you'd almost thought we might have planned that.
Bottom right.
Yeah, he's just thinking about it, Dave.
Well,
perhaps I put the wrong fuel in the car.
Yeah, so we'll just give a few words about each of the ranges. So the ES range, we're looking at 18 modular experiments covering subject matters such as moments, friction, cams, tensile testing, etc. They all sit on a work panel, either in portrait or landscape view. So it's a good introduction to mechanical engineering there, Dion.
In fact, I'm going to be working on the friction experiment this afternoon, filming the next video for that.
You are?
Yes, I am. So hopefully that will be out next week, depending on my levels of success. Okay, let's have a look at the next one.
Let's go to fluid mechanics.
Yeah, here we go.
I'm doing these in no particular order. So this is an extensive range of high quality fluid mechanics experiments, as I said. Teaching and laboratory equipment. We as a company were the first to offer a modular range of equipment for fundamental studies of fluid mechanics. And we cover equipment available for nearly all of fluid mechanics courses. So it's a huge range of equipment there.
Okay, good.
Engines. Let's look at engines. Is that next?
It is engines. Yeah, here we go.
Yeah, so our engines, we cover internal combustion engines. That'll be single cylinder diesel and gasoline or petrol engines. And also we are able to look at our gas turbines. So we offer a turbojet trainer and a 2-shaft gas turbine within the engines range. With the control engineering, we look at control engineering principles, Dion. It offers a range of fundamental through to advanced investigations into control principles, actually using actual applications found in industry. Okay, for example, stability control of aircraft and ships. All of our CE range, control engineering, includes our specialist control CE2000 software that can be used also for simulated control experiments, which kind of brings us on to process control. This range, it demonstrates fundamental and advanced studies of real life processes. Okay, that can be PID, DCS, cascade, control of pressure, flow, level, and temperature. And again, we offer dedicated software that's been developed by TecQuipment to support our process control range. Just take a break. Electrical power systems. Yeah, this provides a range of advanced technical teaching and training equipment for all elements of power systems. And that does include generation, transformation, transmission, distribution, utilization, and protection. And these scalable power systems products, they provide good hands-on learning to power systems with hardware and optional SCADA system and the options of a second generator. Okay. We could also offer a modular power system trainer. That's the PSS1 is the main power system simulator. Then we have the PSL 10 through to 50. So you can add to the modules as and when the need arises or when available budget comes in. Okay.
Right.
What next? Materials. Okay. This is one of my favorite ranges because we get to break things on purpose. We study the properties of materials where testing is a fundamental part of engineering courses. It's a completely comprehensive range from tension to compression. We look at impact, hardness testing, we look at stress and strain analysis, and structural experiments. A lot of this includes or incorporates local digital displays, but also there's the options of data logging as well. So we have manual record taking, but also the options of our data logger. EC or environmental control. This range offers teaching equipment covering fundamental theories associated with thermodynamics, fluid mechanics and heat transfer. So that can be anything from cooling to refrigeration, AC or HVAC, right through to humidity. Okay.
And we have an exciting new product coming soon on that one.
We do. We do.
Right, where were we next? Oh, I've got to fly through again. Just a quick reminder as we get back on track.
Thermo.
And we are going to thermo. There we go.
Here we go. It's coming. There's some lag there. So
yeah,
our thermo range. This is a range of small scale equipment, looking at experiments into the laws of thermodynamics. Okay, and we as a company have included real working systems, again with industrial components and assemblies. Our GT range of gas turbines falls under really this banner. We offer engine test sets that we've already spoken about earlier, again with data logging and so on. So a wide range of teaching equipment in thermo. Structures, well, I can safely say TecQuipment is a market leader in modular structures experiments. We include static fundamentals experiments and 19 structures experiments. The hardware can be used as standalone, or they can opt for the STR2000, where they can do data logging and also perform virtual experiments there, Dion.
Brilliant. Thank you, Dave. Talking about software and virtual stuff.
VDAS.
Yeah.
Yeah, versatile data acquisition system. This is TecQuipment's proprietary software, designed by TecQuipment to work alongside multiple products now in the range. With the VDAS modules, software covers a lot of the range. It's designed to ensure ease of use and a good understanding and error-free in gathering results. It has many features, Dion. There's the options for large displays, and the user can not more than often actually select analog or digital displays on the VDAS home screen. Okay.
I guess it's worth mentioning as well that yes, the hardware comes with the equipment, but the software is free, and that's free for anybody to download. So if you've got students want to downloading it onto their own individual laptops to plug into equipment to do experiments, then there are no limitations there.
No, indeed not. Solar, the solar energy range offers equipment for the core principles of solar energy. Okay. This can be the study of PV cells or photovoltaic cells. We have a flat plate collector, solar thermal energy collectors, and we can offer focusing solar energy collectors, so students can learn about the efficiencies and also the limitations of solar energy.
Great. Right. I believe that's all of it.
Now I think
Or did we miss one? Did I have another one on the list?
I think finally we've not spoken about
theory of machines. There we go.
Yeah, I knew there was one. It felt like there was one missing.
There you go. You should see a gearbox very soon.
Yeah, there we have a typical gearbox there. This range looks and studies and performs experiments from fundamentals all the way through to advanced levels there, Dion. We look at the introduction to the theory and the characteristics of mechanisms and rotating machines. So these can be statics, they can be dynamics, found in the workplace, so shafts, vibrations, and gearboxes, gear mechanisms. So
brilliant.
That wraps up all the tabs, I think.
Yeah, wonderful. So that's a range overview. Before we come to the Q&A section, I want to remind everybody who's watching this live, please do put your questions in the chat box and we'll ask Dave. I've also got a few questions that people have emailed me in advance for this, Dave, so be ready. Right, before that, I'm going to talk about a few things that that we've been working on to deliver more support for academics and students around the world. One of those is the student competition. This is a competition that we run, everybody can get involved. We can do local level competition within the university or the college. So if you want to get involved in the competition, don't worry about the dates on here because it's COVID-19 and all the dates have gone out the window. We are very much open to continuing the 2020 student competition with institutions around the world when you're up and running again. Now, it may be that we're looking to the 2020 student competition, how you might incorporate it into your syllabus or do it as an extracurricular activity. So it's all about creating a video that proves a piece of theory or tests a concept using a TecQuipment apparatus. And it doesn't matter what apparatus it is. And it may be that you have students that are using all different pieces of equipment, studying different things that enter the competition at your local university and college level. We can get together with academics to define the rules. We have a standard rule set, but we can also incorporate rules that need to meet your learning objectives as well. So the idea is that we can help you engage the students more. We provide monetary prizes and trophies. It's all about improving their communications as well, more and more, as you can see today, and currently in this situation, videos used more. So giving students the capabilities, building their skill set in that area is also something that we're encouraging with these student competitions. When we have the best of all the universities and colleges, we have the winner, we put them to the best of the best international competition, and then we'll have a global winner. We won't be having a global winner for 2020 as of yet, because many of the universities that we're looking to work with have had to close down. But we have got the university competition at Nottingham Trent University has run for the 2020, and there are some of the videos that I mentioned earlier, and we'll be announcing the winner of that one very, very soon. If you'd like to know more, please do email me to discuss how you might run a student competition at your institution. Then I also want to mention the survey that we've been working on. Over 2018, 2019, we surveyed over 100 different institutions from around the world. We were looking at the perceptions of practical teaching in engineering education, how important they felt it was for employability, what the motivation was of students, etc. You can see some highlights here. We found that 90% of academics believe that practical learning is extremely important for employability of students. And it'll be interesting to see how academics are dealing with this in terms of COVID-19 as we progress from our current very limited situation that many countries are experiencing at the moment. There is a full area on the TecQuipment website. You could probably Google it and find the results as well with the full executive full paper and report. We've got an executive summary as well that makes it easier to absorb. The idea of this is that it helps give you insight. But it also, if you've got budgets and you're trying to justify spend and you're looking for other measurable terms to justify it, then these statistics may well help you. So that's it from that. Now is the Q&A time, and I really hope that Dave is ready because I'm going to be flying the questions your way. Again, reminding everybody, if you're watching this live, put your questions in the chat box below. If you're watching it on demand, then put your questions in the comment box and we'll type some responses to you. Or join us for next week's Q&A, Wednesday Q&A sessions, and Digital Dave will be there to answer them. Right, first questions, Dave. Entry level. I've got an academic who's been asking me, emailed me recently and said, what kind of equipment, where would I start if I just want to understand a very basics of aerodynamics on my first year mechanical engineering course, what would you be recommending for them?
Excuse me, I'd run budget dependent. I'd go with the AF10 modular airflow bench, maybe in parallel with a subsonic wind tunnel, Dion. So be it the AF1125 or the AF1300. Those two will give a good introduction to aerodynamics. And like I said, the modular airflow bench with its 8 experiments provides a perfect platform, if you like, for getting the bones, getting the subject of aerodynamics understood. It's simple to use. It's very quick to change the experiments over. There's no data logging to cause any issues with the students. They are the data logger. I'd run with the AF10 and the 1125 and or the 1300, Dion. Sure.
Right. Brilliant. Okay. Now I want to talk about the supersonic wind tunnels now. Specifically, what kind of models are we looking at? What are the options there? Because you can't just make your own models to go in those, can you?
No, you can't. No, well, oddly enough, there's just 2 real experiments on the supersonic wind tunnel. The first one, you don't actually use the models at all. You look at the supersonic airflow through a Laval nozzle. Okay, we have a Laval nozzle arrangement because even with the 3 air receivers and compressor on the AF300 intermittent, and despite having the giant vacuum pump on the 302, that still isn't enough to get the air to supersonic through the working section. So we have a nozzle. It's a sudden contraction and then expansion. This accelerates the wind speed to supersonic. So along the working sections on both wind tunnels, we have pressure tappings, and we look at the pressure distribution along the nozzle, and we can see the wind speed increasing. Then it flattens out and then drops from supersonic down to subsonic. So the learning outcomes, it must be remembered, are exactly the same on these wind tunnels, exactly the same. It's just the method at which the air is delivered, okay? The other experiment, apart from pressure distribution, is looking at the shock or pressure waves across and before the 2-dimensional models that fit in the working section. So we have single edge aerofoils, we have double edge models, 5 degrees, 7 degree, 10 degree. Then finally we have a tapped model as well, so we can actually look at the pressure on the surface of the model in the working section. So yeah, it's pretty dynamic.
Okay, and have we got, how much space are you looking at for putting one of these into a lab?
A lot, yeah.
A lot.
Yeah,
and
sure.
I guess you're going to need extra space for the air circulation as well. It's not just the physical space.
Yeah, I mean, the exhaust on the AF302, which is in the background there, that normally the exhaust points to the ceiling, and that is itself is about 9 meters, or maybe perhaps about 2.5 meters, 9 feet, 3 meters tall. So it needs a decent ceiling height, as well as that the footprint of the wind tunnel is big. Okay, I mean, me and you could both estimate now in feet or meters how much it needs. In length, it's at least, I would say, with the clearance and walkways, you need at least 10 meters in length. Okay.
Well, we do, thinking about that, we do have individual videos on this particular piece of equipment. Most of these apparatus in the aerodynamics range, to be honest, we have individual equipment, videos that talk about how much space you need, how tall it is, all of those dimensions, including the learning outcomes and close-ups. So I would encourage you, and I will put some links in the comments box for people to go and see those afterwards.
Yeah, splendid.
Good. Right. Okay. So, which is your favorite bit of equipment in the in the aerodynamics range? Because I know you love aerodynamics, but
Well, it's
what's
got
your...
to be the 302 because it's the boss, it's the king. You know, it provides a continuous supersonic airflow until such a time that you switch off or you haven't paid the electricity bill. You know,
Yeah.
it does take quite a bit of current, but no, that's my favorite. It's actually the easiest of the two to drive because it's continuous. You don't have to worry about running out of air in the receivers, so you can not take your time, but you can go at your own pace, get the data you want without worrying about having to wait for the tanks to recharge. But having said that, the 300, there is a difference in price between the two, and in some cases universities can and do use their own compressor, providing it meets our spec for the air receivers, etc. So they both have their benefits, sure.
Right. Well, that's the last of the questions for us today, Dave. Thank you very much for joining us. Thank you, everybody. We've had a great turnout today. It's been wonderful to see you on live. Those people who put comments in the chat box, it's fantastic. It gives us some live feedback as we're stuck in our home offices, talking away to ourselves and our screens, as we're all getting very familiar with. Again, a reminder, don't forget, next week we will be back. As every week we do the live Q&A sessions. It's Digital Dave and myself. We'll be on Instagram at 1 o'clock British Standard Time, that's GMT +1, and at 2 o'clock on YouTube. You can watch all the YouTube Q&A live sessions on demand by looking at the live stream event, a playlist, along with the Aerodynamics live event that we did last summer, the civil engineering live event we did as well. So do have a look at those as well. So that's it from us today. Thank you very much to everybody for joining us, and we look forward to bringing you another webinar very soon.
Okay.
Thank you, Dave.
Thanks again,
Goodbye.
Dion. Yeah, talk to you soon.